The Fourier Transform. Frequency domain. Joseph Fourier. 1768 to 1830. Why do we learn mathematics? Most math teachers face this question. The Fourier transform might be the best response to convince students. Early humans used grooved lines on cave walls to write their numbers. Calculations got easier with the invention of numbers, which opened the door to endless possibilities. The broad usage of mathematics is changing the world dramatically. For instance, the first audio file format wave used by computers had an average of 50 megabytes per song. That is 5 minutes and lossless and uncompressed. However, the MP3 audio file created by decomposing a sound wave using a Fourier transform has an average of 4 megabytes. This mathematical technique removes what our ears wouldn't hear, then reconstructs a wave that sounds a lot like the original. Every wave, no matter how complex, is made up of very simple sine waves. The Fourier transform, as its given name says, transforms the signal into its sine and cosine components. Fourier transform splits sound waves into a collection of sine waves of different pitches and loudness. Then reconstruct the original sound simply by playing all the component sine waves at the same time. Fourier transform is also used for images. The bitmap file is divided into 8 by 8 pixels blocks. Then each chunk is transformed into a mathematical cosine function by using the discrete cosine transform, which is based on Fourier transform. These wave functions removes indistinguishable information rather than compressing it. The collection of these mathematical functions reconstructs the BMP file into JPEG by using the stored functions. Why don't we use uncompressed files? This would be a fair question if you are an audio engineer or a photographer. However, the internet, most electronics, and all communication systems strongly depend on these compressed or lossy mediums. It's not just the storage issue. Your smartphone, tablet, TV, computer, music player, Alexa, cable, and all similar devices cannot handle uncompressed mediums. You cannot possibly watch Netflix or prime time without seeing a spinner every 20 seconds without Fourier transform. The Fourier transform is widely used in fields such as engineering, physics, and computer science for analyzing signals and systems, such as in image processing, speech recognition, and signal modulation. Overall, the Fourier transform is a powerful mathematical tool that has many practical applications in modern technology and science until we start using quantum Fourier transform in quantum devices.